Hi everybody, can you all see me and hear me? Very good morning. But you just have to give me one moment. Yes, can you all see me? Alright, audible and visible. So as I always say, Namaskara everyone, Andariki Namaskaram, Ellargu Swagatam and a very warm Vanakkam to Vedantu JEE English channel. This is me, your master teacher, Nabamita Ma'am, and today we are going to take a look at redox reactions, everybody. Yes, we are going to complete redox reactions. There will be some PYQs, there will be some questions that we will be solving, and yes, I might also give you a little bit of homework, and you will be getting the notes in the Telegram channel, everybody. So whoever comes to the session later on, please make sure that you guys are the moderators of the class and you let them know that there will be questions that will be done, there will be PYQs that will be done, the whole chapter will be taught. Basically whole chapter, when I say whole chapter, it is a quick revision session. We will be trying to finish the session in 2 hours, everybody. Yes, apart from that, you will be getting the notes in the Telegram channel. And what else? Whatever is related to the syllabus of JEE second mains, that is what we are going to cover. Okay? Alright everybody, so will you all be able to tell them that? Will you all be able to tell them that? This session is going to be around 2 hours, not more than that. Okay, not more than 2 hours, but we will be basically covering everything. Now, before I start with the session, let me tell you that your favorite teacher, your favorite Shreyas sir is going to be in Hyderabad in Nizampet. Everybody, here is the address. He is going to be there in the Vignan School, Kukatapulli, Venkatarya Nagar, Nizampet. Everybody, so whoever is from Hyderabad, all the students who are from Hyderabad, I request you all that please go and visit him. I'm sure that sir is over the moon, over excited, and all of these sessions that you are not seeing, all of it is going to get fulfilled if you go and meet him. I think sir will be out, sir will be just in the cloud 9, everyone, to see you all, and so will you, I'm sure. In this session you will find a you will find a career counseling session, you will get a booklet, and there will be so many other things as well. So just go register yourself and go and meet sir. Sir will be very happy, and if you meet him, only then maybe the other teachers, Ninja ma'am, Durgesh ma'am, I will be able to come to Hyderabad. So go meet him. Yes. Alright everybody, will you all do that? Chalo guys, now let us begin with our session, and let us begin with redox reaction. So when we talk about redox reaction, what do you understand? Redox, the word itself comes from 2 words, that is reduction and oxidation, isn't it? What does it come from? It comes from reduction and oxidation. So my dear students, let us start with what is reduction first, guys. What is reduction? According to the classical according to the classical school of thought, or how do you say it, classical school of thought, yes, as in the old method of thinking, according to that, we know reduction to be only, okay, we only know that reduction is removal of oxygen. What was it? It was removal of oxygen. That is what was considered. Yes, for example, everybody, let us take the example of copper oxide. Yes, copper oxide, when you make it react with carbon, what will happen is you will be getting copper and you will be getting carbon monoxide. So you see removal of oxygen happened for copper. That means copper got reduced, isn't it? Yes. Now coming to oxidation. Reduction is reduction, red, and oxidation, everybody, if you see, oxidation basically was considered to be addition of oxygen only. Okay, this I'm talking about classical school of thought. In the classical times, that is in the olden times, people used to think that oxidation is addition of oxygen and reduction is just removal of oxygen. So when we talk about addition of oxygen, we know that, for example, let's take Mg plus oxygen. What will happen? You will get MgO, isn't it? You will get magnesium oxide. So this is your addition of oxygen, and that is your removal of oxygen. However, as time passed and as the advancement of technology happened, not just technology, basically what happened, more and more experiments were conducted, right? More and more experiments were conducted, more and more research was conducted, and that's when we figured out that, oh, no. Oxidation is not only addition of oxygen, but it can be an addition of electronegative element to a substance. Any electronegative element, when they are attached to a substance, that also means oxidation. Not only that, later on we figured out that removal of hydrogen or an electropositive element from a substance, that is also oxidation. For example, let me give you an example here. Okay, for example here, imagine that if you have H2S, right, H2S plus Cl2, let's say, what will happen? This will become 2HCl plus sulfur. See, so with chlorine or from sulfur, removal of hydrogen happened. Yes, removal of hydrogen happened from sulfur. Don't you see it? So yes, that is also oxidation, my dear student. Later on, they also figured out that increase in the positive charge. For example, iron, you must have seen iron goes from Fe plus 2 to it becomes Fe plus 3, and it loses one electron. So that also is oxidation. Increase in the oxidation number. For example, you must have seen that SnCl2 goes to SnCl4, it goes to plus 4 oxidation state from plus 2 oxidation state, and that also is oxidation. Removal of an electron, everybody, same example from of SnCl2, if we take it, for removal of electron, you will see that Sn from plus 2, it will go to Sn plus 4, and here 2 electrons are being removed, and that, my dear student, is also your oxidation. So this idea is not so classical, but classical idea was only based on that we will just add one oxygen, that is oxidation, we will remove oxygen, that is a reduction. Getting my point, everybody, till here? No doubt, I suppose. Now let us take a look at reduction. So just the ulta of whatever we have done in oxidation, let us take a look at that, and we will be able to figure out what is reduction. Reduction bole to removal of oxygen. For example, what is the example that I gave you just some time back? Did we not see? CuO plus carbon here will give you what? Copper plus carbon monoxide. Removal of oxygen happened from copper, everybody. Check it out. So that is reduction. Addition of hydrogen, bole to, addition of hydrogen. Let me show you an example here. Addition of hydrogen, everybody. Yes. Addition of hydrogen, you will see that, okay, sulfur plus H2, if I add, what will I get? I will be getting H2S, and that, my dear students, what is happening? Sulfur is getting reduced. Sulfur is getting reduced, everybody. Guys, are you not able to see me? What's going on? Are you able to see me or not able to see me, guys? You guys are able to see me and everything, right? Hi Arjun, welcome to the session, bacha. Welcome to the session, everybody. Chalo, okay. Now, addition of electropositive element, that is also counted as a reduction. Removal of electronegative element is counted as a reduction. Decrease in the positive charge, everybody. Okay. The same example of iron that I gave you, if we do it ulta, bole to, check it out, everybody. If we make it Fe plus 3 plus 1 electron, if we add, then what will we get? We will be getting Fe plus 2, isn't it? And that, my dear student, is what? Decrease in the positive charge. There is a decrement in the positive charge that we see, and that is a reduction. Okay. Decrease in oxidation number. For example, KMNO4. Remember KMNO4, everybody? What happened to KMNO4? KMNO4, for example, if I write it MnO4 minus here, that means this is in plus 7 oxidation state. From plus 7 oxidation state, remember it goes to Mn plus 2. That means that right here it is in plus 2 oxidation state. That is also reduction. Addition of electron. Similarly, right here, see, the moment you add an electron, what is happening? There is a decrease in positive charge, and that is also reduction, everybody. So till here, reduction and oxidation, have you all understood reduction and oxidation according to the classical method and according to the newer experiments? Have we understood, everybody? Is there any doubt related to that, guys? Is there any doubt related to reduction and oxidation? Quickly, come on, go ahead, everybody, if there is any doubt. If there is any doubt, quickly go ahead and let me know. I hope there is no doubt. I think all these are self-explanatory, but I still took some time and I explained it to you, right? Everybody has understood. Great. Now, my dear bachus, let us take a look at oxidation and reduction, classical idea, okay? All right, let us take a look at this. But one second, let me just copy this, everybody. I might be, needing some more pages. I'm pretty sure about that. I'll probably need some more pages. So Anyway, chalo. Now, first of all, what are we going to do? Let us understand oxidation and reduction classical idea. Classical idea as in the old method. You know, yesterday only we spoke about it. Classical physics and quantum physics. So yes, there was a classical idea of chemistry, and then came the later part of the chemistry with a lot of study, research, survey, experiments and blah, 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 right? So here, let me write down oxidation and reduction, everybody. Classical method. Okay? Oxidation and reduction classical method or classical idea. Okay? According to the classical idea, everybody, let me give you some examples through which you can understand it a little better. So check it out, everybody. If we take Mg in solid form, okay, Mg in solid form, plus if we take Cl2 in gaseous form, what will it form? It will form MgCl2 in solid form, right? So what is happening with Mg, guys? What is happening with Mg? Magnesium. What is going on with the magnesium? It will undergo oxidation, right? This is undergoing oxidation, isn't it, everybody? This is undergoing oxidation. Does this make sense? Does this make sense, everybody? Similarly, let me give you a little complex example here. One complex example that I did teach you even when I was teaching you for the first time. So let me give you this example. What if we take a complex compound, 2K4, FeCN6, my favorite compound to explain the whole coordination compound, isn't it? Do you think that does this get oxidized? Of course, yes. So this will be in the aqueous form, plus let us say that we add some hydrogen peroxide, okay? If we add some hydrogen peroxide, do you know what it will form? It will form 2K3 FeCN6. Now FeCN6 is the coordination entity, nothing will happen with that, but the counter ion, what will happen to the counter ion? See what happened? From K4 it is becoming K3, and here you will get some amount of potassium hydroxide in the aqueous form. So what is going on? The coordinate complex here is getting oxidized, isn't it? Can we say that it is oxidized? Absolutely, we can say that it is getting oxidized, right, everybody? Yes. Yes. Now you will be like, but ma'am, these are all oxidation. What about some reduction? Chalo, let me give you some reduction example also. Chalo, let me give you. For example, let us say that we take 2HgCl2. Okay? If we take 2HgCl2 aqueous, plus let's say that we take some SnCl2 that is also in aqueous form, right? Now what will happen? What will you get here? You will be getting, my dear students, Hg2Cl2 plus SnCl4 here. This will be in aqueous form. This will be in the solid state. Here what is happening, guys? HgCl2 to Hg2Cl2. Here reduction is definitely happening. Reduction is definitely happening. Is this understood, everybody? Is this understood? अरे प्रणव तुम मार खाएगा बच्चा, मार खाएगा तुम, है ना? तुमको मैं, I am watching you for the last 3 to 4 days. Every single day, what did I tell you? I am the director of the movie. You need to sit quietly, bacha. You can't come in the beginning of the class and ask me something that I am supposed to teach you in the later part of the class. I've started with the session, now you are asking me, ma'am, how do you find out disproportionation? Wait, no, bacha. Do you do this with every Rajnikant movie? Do you go and tell him that, Anna, show some this stunt with the chashma, huh? He will show you. When he has to show you, he will definitely show you. Please don't do that. I've been watching you since the last 3 to 4 days, bacha. Wait up. Everything will be taught. Whenever you are leaving the class, did you have any complaints? Did you have these doubts that, ma'am, you did not teach this, ma'am, you did not teach this? No, right? Then wait up. Please. Don't do this every class. Okay? Don't spam right in the beginning of the class. Chalo. Alright, so is the classical idea understood, everybody? The classical idea is understood, everyone? Yes? Now, moving on, everyone, let us understand oxidation and reduction. But this time we are going to understand it in terms of electron transfer. What are we understanding? Now we're going to understand oxidation and reduction, everybody. Alright? Now let's understand oxidation and reduction, everybody. But this time we're going to understand in terms of electron transfer. Okay? In terms of electron transfer. Now you will be thinking, a little bit of scratching your head will happen that, ma'am, what is this now? Chalo, let me tell you. So initially, classical idea was just removal of oxygen, addition of oxygen. But later on, all these explanations that I gave you, all those things that I told you about oxidation and all those things that I told you about reduction, tell me something, wasn't oxidation, what was oxidation, guys? Oxidation was also loss of electrons, isn't it? Wasn't it loss of electrons? Absolutely it was. Right? That means that I can also say oxidation is basically a decrease in electron density. What is it? It is a decrease in electron density, isn't it, everybody? So you had basically an electron cloud, right? And from that electron cloud, some of the electrons you have lost. The moment you have lost, the heaviness of the electron cloud, won't it reduce? Won't it reduce, everybody? Tell me yes or no, guys. Yes or no? It will reduce, isn't it? So that means we can say that the electron density is decreasing, and that means that this is going to be an oxidizing agent. So, here is a mnemonic that I gave you, and I know that almost everybody knows it. And the mnemonic is, my dear students, oil rig. Okay, what is it? Oil rig. Basically, what you want to say is, you want to say that oxidation is a loss of electron. Oxidation is loss of electrons, and you can say that reduction is gain of electron. Reduction is gain of electron. This is, again, this is not my mnemonic, not discovered by me, but it is what my teachers have taught me. When I was in my 11th and 12th, I had my sir whose name was Rakesh Joshi sir. I was a KV Kendriya Vidyalaya student, so Rakesh Joshi sir, and there was another tuition teacher that I had whose name was Binod Gupta sir. So both of them used to use this, and that is why I am heavily dependent on this, and I am heavily inclined towards this. But if you have any other mnemonic, sure, go ahead and you can use that. Okay? Let me give you another example here, everybody, just so that you are absolutely clear. Let me give you another example, and the example would be, let us say that we take sodium. Okay, we take sodium in solid form, and we are taking Cl2 in gaseous form. All right, what will we get? Of course, we will be getting our famous product 2NaCl, that is solid, everybody. Now, if you carefully look at it, everyone, carefully look at it, what is actually happening here? What is it that you actually see, everybody? So you had Na, right? Na, when it is becoming NaCl, tell me that if you dissociate it, Na plus it is becoming, that means that there is a loss of electron. Yes, there is a loss of electron, everybody. Am I right? So what is this happening? If there is a loss of electron, then what am I going to say? I am going to say that this is oxidation. Makes sense, everybody? This is going to be our oxidation. Am I right? Similarly, my dear students, similarly, everybody, if you look at Cl, okay, if you look at Cl, so Cl2 is becoming Cl minus, am I right? Yes, it will become 2Cl minus, everybody. Am I right, everyone? Look at this. Yes, so here what is happening, guys? Right here, what is happening? Gain of electron is happening, isn't it? Gain of an electron is happening. That means, what can I say? This, my dear student, is for me reduction. Am I right, everybody? So please check it out and tell me, is this understood? Is this understood, everybody? Yes. And if that is the case, my dear students, now let us bust one myth that we all get confused with a little bit too much. And that, my dear student, is your, you know what we get confused with? We get confused with the fact that, just a second here. What is an oxidizing agent and what is a reducing agent? That is something that we do not understand, or we heavily get confused with, isn't it? So let us bust that myth, everyone, today. What is your oxidizing agent, guys? What is your oxidizing agent? Okay. Oxidation is loss of electron. Oxidation is loss of electron. So oxidizing agent is going to be acceptor of electrons, everybody. What did I say? It is going to be acceptor of electron. Makes sense? Nonsense, everyone. Oxidizing agent is going to be acceptor of electron. And now if I tell you that what is your reducing agent? What is your reducing agent, my dear students? Your reducing agent is going to be someone who can donate. So donor of electron is going to be reducing agent. To understand this a little bit more, okay, to understand this a little bit more, let us suppose that You have, who do you have here? Yes. So we have Akshaya. Oh, hi Akshaya. So yes, Akshaya is also a KV student. So let us take a look at Akshaya and Yashwant. Okay. So let us take the example of Akshaya and Yashwant. Okay. Now what happens is that, okay, Yashwant is going to give some money to, or give some money to Akshaya. Okay. Yashwant is going to give some money to Akshaya. Now, in order to give money to Akshaya, what is happening, everybody here? What is happening? Akshaya will definitely respect Yashwant a little bit more. Yes, Akshaya will respect a little bit more to Yashwant, that, oh my God, Yashwant, I was in so much of need. You gave me money, Baba, Re, Baba, thank you so much. Thank you so much. Yes, right. Yes. So the moment, and the more money Yashwant gives, what will happen? The more respect Akshaya will have, that, yeah, bro, thank you so much. Thank you so much. You are the best. You are my best friend. You are the one. I respect you utterly. Yes. So what is happening here? So that means that, what is happening? See, Yashwant is giving money to Akshaya, and in that order, Akshaya is respecting Yashwant more. So Yashwant is getting oxidized respectfully more. He is getting more respect. So let us consider that to be oxidized. So Yashwant is getting oxidized. What is reduced? Now that, okay, just, okay, please Akshaya, do not mind, okay, please do not mind, bacha, okay, okay, please do not mind. See, now look at Pompey. Pompey is saying that aap pagal ho. Great. Now will we respect him or her? We do not know him or her. Will we respect him or her? Do you think that Pompey as a student will gain my respect? Not at all. So while Pompey keeps repeating these mistakes again and again, what will happen? My respect will be going down for Pompey. See, again, a little bit more reduction happened here. See, while they are giving me those comments, what is happening? I'm not going to respond back to it, but they are getting reduced in front of everybody, all the students who are in the class as well as me. So R for respect. Yes, and as you do this, you are not giving me any respect, so I am also not giving you any respect. Am I right, everybody? Does this make sense? Yes, everyone. Does this make sense, guys? Did we understand what is oxidized and what is reduced, everyone, in terms of this money? Yes or no, guys? Yes or no? Any doubt till here, guys? Any doubt till here, everybody? Any doubt till here or no? Any doubt till here? Hi Rajkumar. Are high five. There are so many KV students, it feels, huh? High five to you all. Yes, guys, did we understand all of it? Did we understand all of it, everybody? So suppose one more example I'll give you, okay? One more example. Okay, all right, okay. Now the question that you might ask is, but ma'am, who will give the electrons? We understand that somebody is going to give electron, somebody is going to take electron, but who exactly will give electron? Who will give electron? Baba, okay. See, when Akshaya and Yashwant, when we were talking about Akshaya and Yashwant, okay, what did we say? We said that Yashwant had more money, Akshaya was asking for it, right? Whoever has more money, they are the ones who are going to give the money. So that means whoever has more electron, they are the ones who are going to give the electrons. Yes. So that is what it is. The one who has more money, the one who has more electron, they are the ones who are going to give more electron. So in that way, there is also that, metal activity series. Okay, what is there? We have something called as metal activity series, which gives us an idea about that who is the one person who is going to, or which metal is going to give more electrons. So what do we have here? We have something that is called as metal activity series. Okay, what do we have? We have metal activity series, which gives us a clear idea about who is going to give away more electrons. Okay, so in this metal activity series, you will see that potassium is above calcium, calcium is above sodium, sodium is above magnesium, magnesium is above aluminium, then you have zinc, then you have iron, then you have lead, then you have hydrogen, then you have copper, then you have Ag, and last may you have Au. So Au becomes your noble metal, isn't it? Au becomes your noble metal. Example. Now you will ask me, ma'am, how did we find this? How did we find this? Remember guys, remember that example, that experiment that we had, everybody, where you take a jar like this, okay, you take a jar like this, and here you put in a zinc rod, okay. Let us say that we have put in a zinc rod here. The moment we put in a zinc rod here, and suppose you have here, you have your blue color solution, that is basically nothing but your copper sulfate solution. Let's say your copper sulfate solution. So what happens? After some time, the blue color will go away. After some time, the blue color fades away. Why so? Why does the blue color fade away, guys? Do you remember? The blue color fades away because Zn in the solid form will react with the Cu2 plus aqueous, and what will it form? It will form Zn2 plus copper. Copper in the solid form is achieved, and through these many reactions like this, we understood that there is a metal reactivity, metal activity series. Am I clear, everybody? We will do it, bacha. Yes, we will do it. EAPCT, EMCT, we will do it. Don't worry about it. Okay, right now please understand this. Okay, all right, everybody, do we guys understand this? Any doubt till here, guys? Any doubt till here? Did we understand all of it? Did we understand all of it? Yes, yes. So this basically, this metal activity series, do you know when it is used? It is used when you have something that is called as competitive electron transfer reaction. Yes, in case of competitive electron transfer reactions, okay, at that point of time you will require this metal activity series. All clear? Yes, all clear, everybody? Great. Chalo. Now let us understand what is, okay, let us understand. Do you need to take a look at, everybody, what is oxidation number and all of that? Do you need to understand that? But I guess that oxidation number you all understand. What is oxidation number? It represents the degree of oxidation of an element in a substance. What is it? It represents the degree of oxidation of an element in a substance. Okay? So now that I've told you what is oxidation number, obviously you would want to know, ma'am, how do we assign oxidation number, right? There is probably you would want to know that how do you assign oxidation number. So first of all, let us understand once again what is oxidation number. What the definition that I told you, it's a very simple layman term definition, but right here you can see that it is an imaginary or an apparent charge that is developed over an atom of an element when it goes from its elemental free state to combined state in molecules. So guys, before we understand what is oxidation number, you have to understand that whenever an element is in its elemental form, that is H2, Cl2, S8, right, O2, isn't it, C4, right, all of these, not C4, sorry, P4, right. So whenever you have something in its elemental form, that means in its fundamental state, it will have a zero oxidation state. From that elemental state, when it combines with some other element and it forms a compound, then they acquire a charge, okay? They acquire either an imaginary charge, which is for our convenience, which is for our our easiness, or they actually have an apparent charge. That is your oxidation number. So let us take a look at the rules, okay? Now the oxidation number of any uncombined element, whatever is uncombined element, everybody, they will have zero oxidation states. For example, you will have here H2, yes, H2 will have 0, O2 will have 0, Cl2 will also have 0 oxidation state, okay? Next rule is the oxidation number of a monoatomic ion is equal to the charge on the ion. What is monoatomic? That means that if you look at it, see, Mn plus 2 if I write, that means that what is the charge? The charge that it has is plus 2, okay? The charge that it has is plus 2, okay? The more electronegative element in a binary compound is assigned the number that is equal to the charge it would have if it were an ion. This we did not understand. For example, everybody, for example, now let us take a look at the next one. The oxidation number of fluorine in a compound is always -1, everyone. Now read the third one, everybody. Now read the third one. The more electronegative element in a binary compound. You have a binary compound. Let's say that you have OF2. Okay, if you have OF2, right? Yes, this is a binary compound. There is only fluorine and there is only oxygen, right? This is a binary compound. Is assign the number equal to the charge it would have if it were an ion. Now tell me, what is the charge that you will have? What is the charge if it was an ion? What is the charge that we have, guys? What is the charge? Oxidation number of fluorine. What is it? What is the charge? Fluorine is very electronegative. Fluorine is going to be more electronegative than oxygen. Am I right? And fluorine, if it is an ion, what is the charge that it will have? -1. -1, right? So this is the example. Fluorine will have a -1 charge. And if fluorine is in its ionic form, it will still have -1 charge. Right, everybody? Yes, right, everybody, guys. Did we understand this? Did we understand this, everybody? Yes or no? Yes or no, guys? Did we understand this? Hurry buddy, I will not be able to explain it once again. I will request you that please just, rewind it back a little bit and watch it again, bacha. Okay? Alright. Now moving on, everyone, let us go to the next part. Oxygen has oxidation number of -2 unless it has combined with fluorine. In those cases only, it might show you a +1 or a +2 if it is in its peroxide. If it is in the superoxide form, then it will show you -1, for example, KO2, right? And it is minus half in in its superoxide form, it is -1/2. Yes, if it is in peroxide form, then it is -1, and if it is in its ozonide form, then it is -1/3. Yes, bacha, need students can also watch. For example, everybody, let us write it down here. See, OF2. In case of OF2, what was oxidation? What is the oxidation state of oxygen? Fluorine is -1, -1. There are two fluorines, so -1, -1. That means oxygen will be +2, isn't it? Yes. Now, if I write here O2F2, that means what will be the charge? It will be +1 because it is peroxide. Yes. All right. Now, moving on, everyone. Moving on. Now, look at it. Hydrogen. Hydrogen oxidation number in most of its compound, it is going to be +1. Unless it combines with a metal. In that case, hydrogen can also show you a -1 oxidation state, bacha. How? Chalo, let us take a look at it. Have you heard of LiH? That is lithium hydride. In lithium hydride, it shows you -1 oxidation state. Have you heard of sodium hydride? In sodium hydride also, it will show you -1 oxidation state. Am I making myself, am I making any sense, everybody? Great. Now, in a compound, the elements of group 1 and 2 as well as aluminium will have oxidation number of +1, +2 and +3. Group 1 will have +1 oxidation state, group 2 will have +2 oxidation state, and aluminium will show +3 oxidation state. Am I clear, everybody? And this, once again, if you go back to the periodic properties or if you go back to P block, we have studied this, isn't it? Yes. Now, sum of the oxidation number of all atom in a neutral compound. If the compound is neutral, guys, it is supposed to have 0 oxidation state. And the sum of the oxidation number in a polyatomic ion will equal to the charge that you have, everyone. Yes, am I making sense, everybody? This is clear? Great. Now here, minimum oxidation number of an element is usually group number except oxygen and fluorine. Group number 1, oxidation state +1. Group number 2, oxidation state 2. Group number 13, oxidation state 3. Group number 14, oxidation state 4. Group number 5. Group number 15, oxidation state 5. So similarly, you can find this out. And the oxidation number of an element, group number will be -8 except the metal. So if the moment we go to group number 15, it will be 8 minus 5. That is, it will be 3, everybody. Am I making sense, everyone? Is this clear, guys? Is this clear, everybody? Yes? Is this clear? This is clear, everyone? Do we understand this? Yes? Now, apart from this, okay, apart from this, let us understand that almost all the time hydrogen has +1 oxidation number. Please remember this. This you engrave it in your mind that almost all the frigging time hydrogen will have a +1 oxidation number. Only when it is bonded to metals in binary compounds, it will have a -1 oxidation state. And if we talk about chlorine, bromine and iodine, when they combine with oxygen, they will have positive oxidation number. For example, if you take HOCl, chalo, you know what, let me write this down only, I think that's better, है ना? Let me add a page here. One second, let me add a page here and let me explain this to you. Okay, here, everybody. Here, what did I say? I said that here, please note it down. Cl, Br and iodine, when they combine, okay, when combined with oxygen, when you combine them with oxygen, yes, what will they do? They will have positive, okay, have positive oxidation numbers, okay, they will have positive oxidation number. Yes, Tom and Jerry, I will do it today, bacha. Today, after this class, today I will sit and I will find out how to do this. Okay? I will pakka do it. Pakka. Today evening, I am supposing that I suppose you will be getting a strategy session for these exams. Okay? Don't worry about it. Chalo. So now here, what I'm saying is, for example, if you take HOCl. HOCl is what? Can somebody tell me the name? Can somebody tell me the name? Yes. Can somebody tell me the name of HOCl? What is it called? What is it called? Next, guys, HOClO2. What is this called? And tell me the next one, HOClO3. Do you guys know what are the names of each one of them? The names of each one of them, everybody. Tell me. Guys, come on. Come on, come on, come on, come on, come on. Very good, Sanjay. Very good. Sanjay, you are right. Supriya, a little bit. Slight mistake here. This is your hypochlorous acid. What is this? This is your hypochlorous acid. Okay, what is this? This is your hypochlorous acid. In this case, you know what? Chlorine's oxidation state is going to be +1. Here you have chloric acid, guys. This is your chloric acid. In case of chloric acid, if you count it, the oxidation state of chlorine is going to be +3. And the last one, my dear student, is your perchloric acid. Sorry, I do not know what am I writing. This is your perchloric acid, everybody. And in case of perchloric acid, you will find out that chlorine's oxidation state is +5, everyone. Do we understand this? Do we understand this? Yes or no? Yes or no, everybody? Yes? Great. Okay. Alright, guys. And here is the trick that I was telling you. Let me write down the trick as well. For the trick, everybody, note it down, note it down, note it down. The trick is, here is your group 1, here is your group 2, here is your group 3. Then after that, we directly go to, sorry, not group 3, group 13. Then you directly go to group 14. Then you go to group 15. Then you go to group 16. And then you go to group 17. All right. Then you go to group 17. All right, everybody. Yes, guys. Am I clear? Now, everyone. Okay. Now, let me show you that how can we write the oxidation state. Although I have told you once, but I'm going to tell you this again. Okay? I'm going to tell you this again. So check it out, everybody. But let me be a little perfect while drawing the lines so that we have proper notes here. Hai na? So that we have proper notes here. So just a minute, guys. Let's do this. Here is one line. And here we will draw another line. Okay? Yes. Chalo. So for group 1, everybody, for group 1, what is it going to be? It is going to be 1 that I've just told you. For group 2, we are going to write 2. This is your 2. Okay? For group 13, it is going to be 3. Group 14, it is going to be 4. And after that, group 15, group 16 and group 17 will have maximum oxidation state, which is going to be +5, +6 and +7. So guys, this, what am I writing? I'm writing that this is going to be your maximum oxidation state. Beyond this, they cannot achieve any other oxidation state. Beyond this, they cannot achieve an oxidation state. Am I clear, everybody? Am I clear? Now, guys, are we all ready to calculate some oxidation number? Can we all calculate this, everybody? Let us do this, guys. Let us do this, shall we? Let us do this. Chalo, here we are taking a class. Tell me something. Na2S2O3. What is going to be the oxidation number of sulfur. Sulfur is the one which is underlined here. Alright, sulfur is the one that is underlined here. So tell me everybody, what is going to be the oxidation number of sulfur? Can you tell me? Can you tell me? Calculate it quickly. Calculate it quickly and tell me everybody. Yes. Group number indicates minimum oxidation state only from +1 to +4. Okay? +1 to +3 maybe. After 4, 5, 6, 7, they can, that is the maximum oxidation state. For example, if you take up chlorine or if you take up nitrogen or if you take phosphorus, beyond +5, it will not be able to show you any other oxidation state. Are you getting my point? Are you getting it? Okay? Do you understand? Very good. Who said that? Very good. +2. Well done. +2. CrO5. This is one question that keeps coming everybody in the exam. CrO5. So tell me. CrO5. Cr is underlined. What is the oxidation state of Cr everybody? What is the oxidation? Very good. The butterfly structure. Yes, you have to draw the butterfly structure. You have to draw the butterfly structure everybody. Let me know. CrO5. CrO5 will have +6 oxidation state, guys. Chromium cannot show beyond +6 everybody. Once again, remember from DNF block what Supriya, that's the mistake, guys. That is the mistake. That's what you have to understand. If you calculate CrO5's oxidation state, if you calculate through a formula, it will be wrong. CrO5, it is mandatory to know the structure. It has a butterfly structure everybody, and the structure somehow looks like this. Okay, double O, here O, here O, here O, here O, and these are connected. Okay, so this butterfly structure everybody is the CrO5 structure here everyone. And here Cr, what is the electronic configuration of Cr? Cr has a atomic number of 24, so that means 3d5 4s1. All the 6 electrons can go away. 3d5, 5 electrons, 4s1, 1 electron, 5 plus 1, 6 electrons can go away. Maximum oxidation state it can show is +6 everyone. Am I clear? Please note this down, okay? Please note this down everybody. Okay? Alright? Yeah? Chalo. Next everybody is H2SO5. Once again, find out the oxidation state of sulfur everybody. Find out the oxidation state of sulfur everyone. The oxidation state of sulfur here is +6, okay? For KMNO4, I have just done this. It is going to be +7, everybody. BaO2, barium oxide here. Barium. What can barium show, guys? What can barium show? Barium belongs to group 2. Group 2, that means +2. Can't change. It is going to be +2. And last but not the least, you have CH2Cl2. Okay, calculate this and tell me, guys. CH2Cl2, calculate this and tell me what is the oxidation state of carbon. I'll wait for some time. Quickly go ahead and let me know. Till then, I'm going to drink some water. Come on. Till then, I'm going to drink some water. Come on. Yes. Come on. Go ahead. Very good. Supriya, amazing. Guys, clap for Supriya. I think Supriya is the first one who has answered right now. Come on. Very good. Yes, the correct answer is 0. 0 is the correct answer. Okay? Alright. So, will you all be able to calculate it? Will you all be able to calculate, you know, how to calculate it? I'll show you. In some time, I'll show you. Chalo. Now, guys, here is a question. This question has come in JEE Mains 2020, everybody. Yes, this has come in JEE Mains 2020. Abhishek RS, beta, which world are you in? Covalent compound is taught in chemical bonding. This is a redox reaction, bacha. Shri Ganeshan, sweetheart, I'm taking a session right now, which is a chapter, bacha. I'll have to give you those strategies a little later. Okay? I have recently done a session on how to get 80 plus marks in chemistry. Please watch that. Okay? Please watch that, bacha. Please watch that. Right now, let us continue this. Oxidation number of potassium in K2O, K2O2 and KO2. One is oxide, peroxide and superoxide. But this question is slightly tricky, and you know what? Can I tell you something? That this question was asked by an NTA and NTA had released it. Many students made a mistake here. Many students thought that, you know what is happening here? They thought that K2O, K2O2 and KO2, they thought that oxidation number of oxygen is being asked. But did you read the question properly, guys? Oxidation number of potassium is being asked. Potassium belongs to group 1. A group 1 element can only show you +1, +1, +1 oxidation state, isn't it? So now everybody clap for Supriya and Sanjay. Once again, everybody, both of them are answering me absolutely correct. So yes, it is going to be +1, +1 and +1. You guys are right. You guys are right. +1, +1, +1. That is the answer. Potassium can only show you +1 oxidation state, nothing else. Am I right, everybody? Clear. Great. Okay. Now, my dear students, let us come to something that is called as a fractional oxidation number. Do you think oxidation number can be fractional? Yes, it can be. Just some time back, do you remember that we calculated it? Just some time back only we have calculated it, and we showed that in a superoxide form, it can have -half. -half is what? Fractional only, no? -half is what? Fractional only. So yes, how is that possible? You calculate. Calculate. And what about the rules? I've just told you the rules, isn't it? I have showed you all the rules. Hari, what are you doing? How is that possible, it seems? Chalo, you know what, Hari? Okay. Sanjay and Supriya, explain to Hari, how is it possible? How is it possible? How is it possible? Also draw the structure. Draw the structure and calculate it. You have oxide, peroxide, superoxide. What happens in a peroxide? Remember that book-shaped compound it forms, hydrogen peroxide. The book-shaped structure it forms. Then calculate it. Then calculate it. Chalo, moving on here. Some elements in a compound, yes, they can have oxidation number which are in fractions. For example, you have carbon suboxide. Yes, carbon suboxide, notes of equilibrium, coordination. Muthu Lakshmi, you still did not. I will definitely do this. I will send it to you. Today after this session, when I send you this notes, together I will send you DNF coordination compound also. Don't worry about it. Okay? Pakka. I'll send it to you. I'll send it to you. Don't worry about it. So here is it, everybody. Oxidation number of carbon is 4/3. Check it out. Then you have Br3O8. You know what? Bromine's oxidation state is 16/3, everybody. For Na2S4O6, you find that the oxidation number of sulfur is 2.5, everyone. So electrons cannot be shared, right? Or it cannot be transferred in fractions. Do we understand this? We understand this, isn't it? Don't we understand that? How can half of the electron go and travel somewhere else, guys? Half of the electron cannot travel, right? Supriya, Hari was asking that how come oxide, peroxide and superoxide, in case of potassium, they still have +1, +1, +1 oxidation state. Yes. Yes, Hari, see, Sanjay has explained. Bacha, potassium belongs to which group? Potassium belongs to group 1. In group 1, what is the electronic configuration? The electronic configuration is NS1. That means they have only one electron in the outermost shell, and they can only lose that to form a bond. That means that they can only show +1 oxidation state. You getting me? You getting me, everybody? Yes? You getting it, everyone? Right? Hari, now do you understand why it is showing you just +1 oxidation state? Potassium belongs to the group 1, right? It can't help it. It can only do away with +1 oxidation state. Okay? Yes. Yes. Alright, guys. Now, moving on, everyone. So, electrons cannot electrons cannot be transferred in fractions. We understand this. This is absolutely common sense. We understand this. But here, how are we figuring out fractional oxidation state? Well, that's because we are not actually saying that electrons are being transferred in half and half or in fractions, but we are actually calculating the average oxidation state. What are we doing? We are calculating the average oxidation state. My dear bachos, I do not know why is this happening. Why does this happen? But chalo, Let me just blacken this up and let me draw the structure of it again. Okay? Here. So carbon suboxide, okay, carbon suboxide C3O2. How is it done? C3, C double bond O, C double bond O, C double bond O. Last mein here you will have two double bond O oxygen, double bond O oxygen, okay. Now if you calculate this carbon right here, everybody, this carbon, my dear students, bachcho, please check it out. This carbon right here at the center, it will have zero oxidation state, am I right? Zero oxidation state. If you calculate zero oxidation state, this one will have +2 oxidation state, am I right? And this one will have +2 oxidation state. Now since there are three carbon, if we take the average, what will happen? The average will be +2, +0, +2 divided by 3, because there are three carbon. That means that it will show you 4/3. Make sense? Nonsense, everyone? Make sense or nonsense, everybody? Yes? Make sense or nonsense, everyone? Clear hai? Great. Now let us take a look at everybody Br3O8. Shall we do it? Br3O8. Yes. So for Br3O8, let us draw the structure, everybody. Okay. So you will have Br, and Br here, right? Now oxygen, 8 oxygen, guys. So it will be double bond O, 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 and here also double bond O, and this one will have double bond O, double bond O. Cool. Now guys, we want to figure out the oxidation state of each of this bromine, isn't it? So if you see, the terminal bromine will have +6 oxidation state and +6 oxidation state, because -2 into 3. -2 into 3 is what? -6. So this means that means that these guys will have +6 oxidation state. And here, this bromine will have +4 oxidation state. Am I right? Absolutely, absolutely. Now, let us calculate the average, everybody. Let us calculate the average. What will happen? We will have +6, +4, and +6 here, everybody. So here we will have 3. That means that it is going to be 16/3. Make sense? Make sense or nonsense, everybody? Make sense, guys? Great. Next, everyone. Next question. Chalo, next. This is Na2S4O6. Please, this pay attention. Pay attention. Hari, virtual pitti. Virtual pitti upcoming. Match you are asking, huh? Pay attention in redox now. Otherwise, I'll get angry, okay? Hari. No match. No match. Pay attention here. Chalo. See, this is the structure here. This structure is drawn here. So here, if you check it out, +2, -2, -2, -4, and 1 minus. That means +5 oxidation state for the terminal sulfur. Similarly, this will also have +5. But these two, the central sulfurs, they will have 0 oxidation state. Am I right? So that means that what can we do? 5 + 5 divided by 4 sulfur. That means 10 divided by 4, which is nothing but 2.5. So have I proved it, everybody? Apart from this, everybody, you know the mixed oxide that you have, the mixed oxides. Remember the mixed oxides, guys? Pb3O4, plumbum. We have read in P block. P block, everyone. P block group 15. So if you look at those, okay, Pb3O4. What is Pb3O4? Pb3O4 is a mixed oxide of PbO dot what? Dot Pb2O3. It's a mixed oxide. Two oxides are mixed together. So Pb3O4, Mn3O4 and Fe3O4, these guys also have fractional oxidation state because of their mixed oxide nature. Am I clear? Am I clear? Acha, bromine ka here it is, but we are done with bromine, right? So do I need to do it again? No, right? I don't have to do it again, right? Yes? Clear hai? Acha. Now here, my dear students, we come across something that is called as stock notation. What is stock notation, everybody? Chalo, let us take a look at it. What is stock notation? Let us understand, okay? Stock notation was actually given by a scientist, yes, German scientist whose name was Alfred Stock. Yes, who gave it? This was given first by a German scientist and his name was Alfred Stock, my bachos. Okay? So Alfred Stock, what he said was that oxidation number can be expressed in Roman numeral. In parenthesis. What is parenthesis? Parenthesis basically is everybody bracket, right? And then after the symbol of the metal, for example, chal. No. Let me write down the sentence first so that you have the stock notation. By chance, if you forget what is stock notation, you have it. Okay? All right. Thank you so much, Namah Shivaya. Thank you so much. Just so sweet. Thank you so much. You just made my day. Thank you. So you're writing it down, everybody, that oxidation number is expressed in Roman numeral in parenthesis after the symbol of the metal. Okay? For example, now let me teach you. SnCl4 if we take, okay? What is this? This is stannic chloride. So how do you write it? You will write here Sn, and this is in 4 oxidation states. So see, in Roman numbers I have written 4, but in a bracket. That means it is what? Parenthesis. What is it? Parenthesis, and that is how you write your oxidation number. Clear hai? So till here, is there anybody who is having any doubt? Yes, guys. Any doubt? I hope till here nobody has any doubt. Hey? Hari, what are you asking? Bio? This is a JEE channel, bacha. Where will you get bio here? JEE does not have any bio. Yes. Namah Shivaya, once the time comes, I will do it. Okay? So till here, nobody has any doubt. Great. Chalo, moving on. Chalo. Here, now, let us come across types of redox reactions. So there are different types of redox reactions, as we all know. And the first one that we will be reading about is your combination reaction. Okay? What is it? Combination reaction. Okay? All right. Second one that we will read about is your decomposition reaction, my dear students. Yes, what will we be reading about? Decomposition reaction. Next one will be, everybody, next one will be displacement reaction. Okay? Next one will be displacement reaction. Supriya, can you please check? Supriya and Sanjay, can you please check what Namah Shivaya is asking? Can you please help him out? I will just move forward. Yes. And the last one, everybody, that we will be talking about is disproportionation reaction. That, my dear students, Pranav and all the other students, you guys were asking me about, ma'am, what is disproportionation? That's the last type of reaction that we will be studying about. Okay? We will be studying about the last one will be disproportionation reaction. So now let us start with our combination reaction. So what is combination reaction, guys? Combination reaction can be very simply explained as a combination. That means an addition is happening. X plus Y is forming Z, let's say. Okay? That means that either X or Y, both X and Y must be in the elemental form for such a reaction to proceed as a redox reaction. You guys understanding? What did I say? I am telling you, my dear bachos, that either X or Y, either X or Y, or both X and Y, or both X and Y must be means that it is a mandatory thing that must be in the elemental form, must be in the elemental form for such a reaction, to be a redox reaction. Okay? For such a reaction to be a redox reaction. Now you will ask me about example. Obviously I'm guessing. So what is going to be the example? The example, my dear students, you all know carbon in its solid form. See, it is in its elemental form. Oxygen in gaseous state. See, elemental form, zero oxidation state. When these two form CO2, this is a combination redox reaction. Getting my point, everybody? Are you guys getting my point, guys? Yes or no? Yes or no? Are you guys getting my point, everybody? Yes? So this is your combination reaction. Now we guys are going to understand decomposition reaction, everybody. Shall we? Yes? Let us understand decomposition reaction. Chalo. Very good. Yes. Combustion of carbon. Very good. Very good. Very good. Yes. Yes. Chalo. Now let us understand what is decomposition reaction, guys. Okay. Decomposition reaction, my dear students, is going to be, everybody, it's just the opposite of combination reaction. Absolutely the opposite of combination reaction. That means we can write it as Z now decomposes to form X plus Y. Okay? Z now decomposes to form X plus Y, everybody. Yes, here let us take a look at it. For example, if you have H2O, okay, let us say that we have H2O. Here you see that hydrogen will be in +1 oxidation state and oxygen will be in -2 oxidation state. Now what will they form? They will form here 2H2. Yes, in this case hydrogen is in elemental state, so 0 oxidation state, plus if I take oxygen here, that is also in 0 oxidation state, elemental state here. Yes, so what is happening? Hydrogen is getting reduced. Can you see, from +1 to 0 oxidation state? So hydrogen, what is happening to hydrogen? Hydrogen is getting reduced, है ना? Reduction is happening. So let's write here reduction. Yes, let's write here reduction. Reduction is ongoing here. Yes, and if you look at oxygen, oxygen goes from -2 to 0, everybody. Acha, so from -2 to 0, what is happening? An increment is happening. An increment in the oxidation state is happening. -2, then 0, isn't it? -2, -1, 0. So here, what do we write? Here we will write oxidation. Here we will write oxidation. Now, all decomposition reactions are not redox reaction, guys. You have to understand this, okay? All decomposition reactions are not redox reaction, guys. Yes, it is not. For example, everybody, for example, writing this down, guys, writing this down here, please understand that all decomposition reaction are not redox reaction, are not redox reaction. For example, if you have CaCO3, which is in solid form, when this decomposes, it forms CaO in solid form, plus it forms CO2 in gaseous state. This is not a redox reaction. This is not a redox reaction, everybody. Acha, now Akash Krutik is asking me decomposition of potassium manganate. Potassium manganate? MnO. What are you asking? Potassium permanganate and potassium manganate. That one. Akash Krutik, couldn't understand your doubt. Can you please rephrase your question and ask me again, bacha? Chalo, no problem. Now, moving on, let us understand displacement reaction. Metal displacement reaction and non-metal displacement reaction, there are two types. And yes, some of you have already said that double displacement is also there. We will talk about that also. Okay? We will try and talk about that also. However, I don't think that we require double displacement reaction to be understood so much here. But no worries. We will take you through it. Okay? We will take you through it. Okay? Don't worry about it. Okay? Alright, guys. Yes, everybody understanding? Everybody understanding? All of you are understanding? Bacha, that's a disproportionation reaction, by the way. I think that's a disproportionation. We will talk about it. Wait, don't confuse me now. Don't confuse me now. Okay? Very good, Hari. Very good. Very good. Yes, well done. Well done. Well done. Well done. Okay. Chalo, guys, let us move ahead. Let us move ahead, everybody. Yes. Shall we move ahead? Displacement reaction. Everybody ready? Everyone is ready? Yes? Chalo. So for displacement reaction, what can we write? We can write that a metal in a combined state, in a compound, right? A metal in a combined state, it can be displaced by another metal, right? In uncombined state. So let me write down the definition here. The definition is a metal in a combined state, a metal in a combined state, yes, can be displaced, okay, can be displaced by another metal, okay, can be displaced by another metal in the uncombined state, in the uncombined state, all right, in the uncombined state. For example, okay, this is my a special example, everybody. How many of you are fans of Harry Potter here? How many of you are Harry Potter? Tell me. How many of you are Harry Potter fans? How many of you have read Harry Potter or you have watched Harry Potter? Come on, guys. No? No, really? Okay. All right. Okay, but at least you know the main characters. You know the main characters, right? There is Harry Potter, there is Hermione Granger, and there is Ron Weasley, right? Yes, everybody. So these are the three main characters. Am I right, everybody? Now, so this is my example of displacement reaction, everybody, that I give you. So let us talk about it. So let's say that you have Hermione. So if you remember, Hermione was what? Muggle blood, right? Hermione was a Muggle born, right? She was born to parents who did not know magic. So Hermione was coming alone to the Hogwarts school, right? But if you remember, Ron and Harry, they were very good friends from the time Harry got to know that he is a wizard. So both Ron and Harry, they were very good friends. Am I right? Yes. But by the end of the Harry Potter series, guys, what happened? We saw that Hermione and Ron, they got married, and Harry was kicked alone, and Harry was lonely. I am so lonely. Not like that. Harry fell in love with Ginny, obviously, but yeah, that is basically something like that happens. Yes. So what can we write? Can we write here, everybody? Now if you try and use the same analogy for metals, you will find that suppose Hermione is X here, okay, and suppose Ron and Harry are YZ here. So what happens is you get X and Y together, and Harry, which is Z, that is kicked out. Okay, so this, my dear student, is your displacement reaction. And here you have two different types of displacement reaction. One is called as your metal displacement reaction. What is it called? It is called as metal displacement reaction. And the second one is called as non-metal displacement reaction. Yes, second one is called as non-metal displacement reaction. Am I clear, everybody? So is displacement reaction understood, everybody? Yes, is displacement reaction understood? Great. Okay. Now, everybody, let us understand what is this metal displacement and what is this non-metal displacement. Shall we, everyone? Yes, let's do that. Chalo. 1 second, let me blacken this up. Let me blacken this up, everybody, and now let us write it down here. Okay? Yes, so we have first metal displacement. What is metal displacement? Ayo. Sorry guys, sorry. One more time, okay? One more time. I erased it. Sadly, I erased the whole black thing. Done. Okay. Yeah, here we have. So now, let us talk about metal displacement. What is metal displacement? In this case, what the definition that I told you first, a metal in a compound can be displaced by another metal which is in the combined state or uncombined state. When it is in the uncombined state, right? For example, everybody, you have CuSO4 plus Zn, okay? Now Zn is 0, and in case of copper sulfate, what do you see? Copper is in +2 oxidation state, sulfur is in +6 oxidation state, oxygen is in -2 oxidation state, and what does it form? It forms ZnSO4 plus copper. So copper becomes in 0 oxidation state, and similarly here you have +2 +6 -2. This is your metal displacement reaction. This is your metal displacement reaction. Clear hai? Next, everybody, is your non-metal displacement reaction. Non-metal displacement reaction. What is your non-metal displacement reaction? So you have all the alkali and some alkaline earth metals, right? They are very good reductants. What are they? They are very good reductants, and they can displace hydrogen from water, cold water, everybody. So that is when you get a non-metal displacement. So check it out, everybody. So if you have sodium, yes, if you have sodium plus if you have water, what will you get? You will be getting 2NaOH plus H2, my dear student. The metals which do not react with cold water, they are also capable of displacing hydrogen from acids. For example, Fe, yes, Fe plus 2HCl, if we take, what will we get? We will get FeCl2 plus H2. See, it is liberating hydrogen gas, yes. And the noble metals which may occur in the native state, they do not react with hydrochloric acid at all, okay? They do not react with hydrochloric acid at all. And last but not the least, everybody, let us study about disproportionation reaction, and this I'm going to write it down just so that you guys do not mix up or you guys do not forget. Everybody call up all your friends, all those friends who are asking about what is disproportionation, what is disproportionation. Call them up, everyone, call them up. Quickly call them up, because I'm going to take this and I'm not going to repeat, everybody. Yes, I'm not going to repeat. So here, an element in one oxidation state is simultaneously oxidized and reduced, okay? And reduced. It is oxidized and it is reduced. And for this reaction to happen, everybody, one thing that is very, very, very important is that one of the element or one of the reacting substance in this type of reaction will always contain an element that can exist in either higher oxidation state or in lower oxidation state. That means it has to exist in at least 3 oxidation state. Am I clear, everybody? So let me write this down here. One of the element, let us say reacting substance here, okay? One of the element, reacting substance, okay? In this type of reaction, will always contain an element that can exist in at least 3 oxidation state. Are you getting it? In at least in 3 oxidation state, if it can exist, only then we will have a disproportionation reaction. Now, for example, everybody, check it out. Let's say that we have H2O2. Okay, if we take 2H2O2, you see that hydrogen is in +1 oxidation state, and because it is peroxide, oxygen will have -1 oxidation state, and the moment it decomposes, it will form H2O, where oxygen goes to -1 oxidation state, hydrogen is still in +1 oxidation state, and it goes to 0 oxidation state. That means what is happening? From -1, it is reducing to -2, as well as it is also increasing to 0 oxidation state. So you see that oxygen is getting both oxidized as well as reduced simultaneously, everyone. Is this clear? And this is your disproportionation reaction. Okay, this is your disproportionation reaction. Now coming to oxidizing and reducing agent, once again everybody, let us do a quick, what do we do? Let us do a quick revision everybody. Yes, oxidizing agent or oxidants, who are the ones? They are the acceptor of electrons everybody. They are the acceptor of electrons. And who are this reducing agent or reductants? They are donor of electrons. Okay, what are they? They are donor of electrons. Yes guys, everybody, are we clear? Now the question comes that, ma'am, how will we identify which one is oxidizing and reducing agent? First of all, you find the oxidation state of the central atom. If the oxidation state of the central atom, my dear student, is, okay, if the oxidation state of the central atom, my dear student, is what? If by chance it is maximum, if it is maximum, that means the valence electrons, if it is absolutely valence electron, that means that it is an oxidizing agent. Okay, that means that it is an oxidizing agent because it can only gain electron. And what did I say? Acceptor of electron will be oxidizing agent. Once it has lost all the electrons. Suppose manganese at +7 oxidation state, can it be a reducing agent? Can it lose more electrons? None. It can only gain more electrons. So that means that it is going to be an oxidizing agent. Then, if the oxidation state is minimum, if it is absolutely minimum, that means that there is a chance that it can lose more electrons, right? It can lose more electrons. For example, nitrogen, phosphorus, right? Phosphorus can show you a +1 oxidation state, but that's minimum. From +1, it has a tendency to go to +5 also. Suppose chlorine can show you -1, but from -1 it can show you +5 also, right? So yes, that means that it is going to be a reducing agent. But if it is in the intermediate, that means that it is not maximum, it is not minimum, then it can act as a both reducing agent or as well as an oxidizing agent, and there is a possibility that it will go through disproportionation reaction. So this is how you identify. Once again, this is a cheat sheet. I'll be giving it to you. Write it down and know where and what all you have to add, everybody. Is this clear, guys? Yes. Now, somebody was asking me, ma'am, can you please balance it? Can you please balance it? Can you please balance it? So here, let me tell you how can you balance your reaction. There are two methods. One is your oxidation number method, okay? One is your oxidation number method, everybody. What am I writing, guys? Wait. Let me write this properly, okay? Oxidation number method, and the next one is half reduction method. Okay, half reduction method. Cool? Yes. Now this half reduction method has again two types. That is the half reduction method has your oxidation half, and it obviously has your reduction half as well. What does it have? It also has reduction half, everybody. Okay? Alright, so chalo, let us start with oxidation number method, shall we, guys? Let us start with oxidation number method, and here is your example as well. So suppose you have copper plus NO3 minus in aqueous medium, which forms NO2 plus Cu2 plus, and this is an acidic medium. Please check it out, guys. This is an acidic medium. Okay? Now step number one, everybody, for us is write the oxidation number of each atom. Write the oxidation number of each atom. So let us write down the reaction once again, everyone. Cu plus NO3 minus in aqueous form is forming NO2 plus Cu plus 2. Now Cu is in its elemental form, everybody. Do you all agree with me? Cu is in its elemental form, everybody. Am I right? Am I right, guys? Cu is in elemental form, everyone. You know what? Let me move this side. I think that's better. Right? Cu is in its elemental form. That means that it will have zero oxidation state. Am I right? That means that it will have zero oxidation state. Now for nitrogen, if you calculate O3, so -2, -2, -2, but there is a minus. That means it will be That means, so O3, this is in -2 oxidation state, but nitrogen, for nitrogen, see, 3 oxygen, -2, 3 2s are -6, but there is a -1 as well. So if that goes that side, then that means that nitrogen will have +5 oxidation state, am I right? Yes. Next, it will be in +5 oxidation state, am I right? Now, here if you check it out, nitrogen will be in +4 oxidation state, and oxygen will be in -2 oxidation state, and here copper is in +2 oxidation state, which is written. Correct, everybody? Now, for copper, if you see copper, the oxidation state has increased by 2. It has increased by 2. Am I right, everybody? Yes, am I right? That means that 2 electrons are being given and taken. Am I right, everyone? Yes. Am I right, everybody? Yes. Correct, everybody? Alright. But if you look at nitrogen, the oxidation state of nitrogen is reducing by 1, decrease by 1, isn't it? Yes. But if we multiply it with 2, here also we are getting 2 electron, am I right? Here also we are getting 2 electron, am I right? Yes, everybody. Now step number 2 is, the step number 2 only we did. Show the increase and decrease. We have done the increase and decrease. We have showed it, right? We have showed it, everybody. Cool? Alright, yes. Okay, and what I have done is, now let us, the next point is balance the increase and decrease in oxidation number. How did we balance, everybody? How did we balance? See here, Cu 2 plus 2. Yes, increase by 2. Increase by 2 into 1 is equal to 2 electron. And here it was in decrease by 1. Here this was decreased by 1. So 1 into 2 is equal to 2 electron. Can we do this, everybody? Yes. Can we do this, everyone? Can we do this, everybody? Yes, guys. Once this is done, now we are going to balance all the other atoms except hydrogen and oxygen. Okay, except hydrogen and oxygen, we are going to balance all the atom. Now let us write it down. Let us write it down, everybody. So we will have Cu plus 2NO3 minus, remember, see, 2 electrons. So hence I have added here 2. Okay, all right. This will be forming 2NO2. Alright, and you will be having Cu2 plus, right? Cu2 plus, but, oh, in the reaction, do we also have O2? Nah, no O2. But guys, check it out. If you check it out, 2 3s are 6 and 2 2s are 4. Only 4 oxygen has been used up, right? But now the reaction takes place in acidic medium. So that means that 2 oxygen are less. We can write it as oxygen here. Done? Yes. Now that the reaction is taking place in acidic medium, that means that we will also have some amount of H plus, है ना? Some amount of H plus. So here we will see that Cu plus 2NO3 minus, yes. So because, okay, wait. So here you have 2NO2 plus Cu2 plus, am I right here? Yes. And you have here oxygen, everybody. Yes, you have oxygen here, right? Now, this side I can write here, 4H plus, and this side I will be writing here 2H2. Yes. In basic medium, what will you do? In basic medium, instead of H plus, you will be adding OH minus ions. What will you be adding? You will be adding OH minus ions, everyone. Yes, yes. Alright guys, did we understand how to do this? Did we understand how to do this? Yes. Now, let us continue with our half reduction method, okay? Let us consider half reduction method. Shall we, guys? In the half reduction method, what do we do? Chalo, let's check it out. In the half reduction method, guys, the step 1 that we take care of is, step 1, everybody. Please pay attention, guys. Please pay attention. Please pay attention, everybody. Yes, please pay attention. The first thing that we do is split the equation into half reaction. Okay, what will you do? You will split the equation. You will split the equation into half reactions. Okay. First of all, half reactions bole to oxidation half and reduction half, right? You will split it into it seems. You will split it into oxidation half and reduction half. Clear hai? Yes. Now, next one, what will you do? In the next step, guys, what will you write is, you will balance the atoms, but not oxygen and hydrogen, okay? Balance the atoms. Balance the atoms other than oxygen and hydrogen in each half reaction individually. Cool, everybody? Understanding this? Next point. Now what will you do? Now you will balance hydrogen and oxygen atom in each half reaction individually. Okay? But what will you add? You will only be adding H plus or H2O. Nothing else is allowed. Okay? So you will be balance hydrogen and oxygen atoms in each half reaction, yes, individually, yes. And what will you be adding? By adding, what will you be adding, guys? I've just told you, by adding H plus or H2O. That's it, nothing else, everybody. Okay, nothing else. And last one will be balance the charges. Okay, what will you do? Here you will be adding balance the charges. Okay, how will you balance the charges? Yes, like Sanjay said, multiply it by multiply it by appropriate coefficient. Okay, multiply it by some appropriate coefficient and each half will done. And the last step, everybody, is add the half reactions and achieve your overall reaction. Okay, what will you do? You will add the half reactions, and achieve overall reaction. Clear, everybody? Yes, guys. Do we understand this? Correct? Yes. Now this is basically your chart, but I think we can leave the chart. I mean, we don't really have to do it, but if you want me to write it, I can write it down here as well. Chalo, let me write it down only. Okay, first of all, what do? You will write separate half reactions. Okay, write separate half reaction. Just for your clarification, I'm doing this twice, everybody. Check it out, repeating it basically. Okay, yes, write separate half reaction. One will be your oxidation half, reaction, and the other one will be your reduction half reaction. Am I right? This will be your reduction half reaction. This side, what will you do? You will balance oxidation half. Yes, and this side, what will you do? You will balance the reduction half, everybody. Balance the reduction half. Am I right here? Okay. Then what will you do? You will add the half reactions, right? You will add the half reactions. But when will you add the half reactions? After equalizing the electron transfer. In both the sides, you will have to equalize the electron transfer. And finally, make sure that cancel the identified species, check the reaction, and make sure that nothing is out of place. Okay? Alright, everybody? Clear hai, guys? Shall we try to see one such reaction with each and every step? Shall we see one such reaction with each and every step? Let us do it. Chalo. Let me take an example of MnO4 minus. Chalo. Let us do it. MnO4 minus. Guys, please pay attention. This reaction has come in your exam quite a lot of times. Okay? Quite a lot of time. What is an acid with so much attitude? I don't know. Which acid? Is it formic acid because it is formal? Because it's in the form? Please tell me. That's a good chemistry joke. I would like to know the answer. Chalo guys. Let us take MnO4 minus. This is given in your aqueous state. Okay. Then you have your sulfur dioxide. Alright. Then here, what is it forming? It is going to form Mn plus 2 plus HSO4 minus, and this will also be in aqueous form. Okay. So what is our first step, guys? Our first step is, everybody, split the equation into two halves. Okay. Split the equation into two halves. So our first step, everybody, will be MnO4 minus, where Mn has plus 7 oxidation state. It forms Mn plus 2. That means this is our reduction half. And here on this side, everybody, we can write this side amino acid. Oh, okay. All right. Okay, this side we can write SO2 is going to form HSO4 minus. That means that it goes from plus 4 to it goes to plus 6 oxidation state, right? So this is your reduction half and this is your oxidation half. Am I right, everybody? Yes. So we have split it. Okay. Now second, what are we going to do? Second, we are going to balance Mn, manganese and sulfur. Shall we do it? Balance manganese and sulfur. Do you see any difference? No. Mn is balanced. Sulfur is also balanced, right? Sulfur is also balanced. So we can just write here that we are going to balance Mn and sulfur, and we have just checked that both of them are same, right? Both of them are similar on each side. That means they are balanced. Okay. Now third one is balance. Third step is, what are we going to balance? We're going to balance oxygen and hydrogen. Chalo, let's do it. So for this side, everybody, for this side, what can we do? For the oxidation side, see, MnO4 minus, it is forming Mn2 plus. Am I right? That means this side oxygen is there, this side oxygen is not there. So let's add oxygen. How do we add it? We are going to add H2O. MnO4, that means 4 oxygen we need. How do we get 4 oxygen? We can write it here 4 H2O. Can we do this? Can we do this? If I write here 4 H2O, that means 4 into 2, 8 hydrogen. So here I will have to add 8 H plus. Am I right? See, balanced, everybody. Balanced, okay. And this side, my dear bachos, this side, check it out. See, we have SO2, which forms HSO4 minus. Am I right? Now this side you have oxygen 4. Okay, this side you have 4 oxygen, this side you have 2 oxygen. We have to balance it. So 4 oxygen and 2 oxygen, that means we still need 2 oxygen. So can I write it 2H2O because 2 oxygen? Now that we have 2 2s are 4 and here 1 hydrogen is there already. So that means 3H plus. Balanced, everybody? Balanced, yes. Now what do we have to do? Fourth step, everybody, is balance the charges, okay? Your fourth step, everyone, is balance charges. Balance the charges, everyone. See, on the left hand side, here what do you have? Here you have -1 plus 8, everybody. See, my plus 8 here, plus 8 here, plus 8 here. Am I right? Plus 8, and there is only 1 minus charge, everyone. Check it out, guys. Plus 8 and here is your -1 charge. Am I right? Very good. So let's balance it. LHS, this side on the oxidation side, what do you have? -1 plus 8 is equal to 7. Am I right? Now this side, if you see, everybody, you have 2 plus. That means this is going to +2 state. So that means that here you have -5 electron will give you +2. Am I right? This is balanced. On the RHS, if you see, on the RHS, this side is +2 anyway. This side is +2 anyway, right? Right, everybody? Now come to this other half of the reaction. Here, see, LHS. Is there any charge? No charge. So you have 0 here, okay? And here, this side you have -1. See, -1 plus 3, which is equal to +2. Yes. So +2 minus 2 electron will be balancing out to 0, everybody. Am I right? Am I right, guys? Am I right, everybody? Okay. Here now we need to add a page. Here now we will have to add a page. Where is it? Just a second. Now what do we have to do? Now we have to write the whole reaction, all the other half of the reaction, and write down the overall reaction. So chalo, let us write it down. What do we have? We have MnO4 minus plus 8H plus, which forms Mn2 plus, right? Plus it forms here 4H2O, if you remember. Also electrons, forgot to add the electron, guys. Here you will also have 5 electron, if you remember, right? 5 electron will also be there. Am I right? Yes. Moving on. Next one, what do you have? Next one, you have SO2 plus 2H2O to balance. Yes. And this side you have HSO4 minus plus 3H plus. And if you remember, 2 electrons we had. So plus 2 electron to balance out 0, 0. Now what we can do, this side is 5 electron, this side is 2 electron. That means this one we will multiply it with 2 and this one we will multiply it with 5. Now it's time for us to write down the overall reaction. So what will we get now? After multiplying, chalo, 1 second. After multiplying, now guys, check it out. What will we have? We will have, everybody, we will have 2MnO4 minus, because multiplied with 2, yes, plus 2 8s are 16, so 16H plus 2 5s are 10, so plus 10 electron. Am I right, everybody? Moving on, 2 multiplied with Mn2 plus, so 2Mn plus 2, everybody. 2 4s are 8, so 8 water molecules. Am I right, everybody? Yes. Then 5 multiplied, so 5SO2 plus 5 2s are 10, so 10 H2O. Correct? This will give us what? 5 into HSO4. So it will be 5HSO4 minus 5 3s are 15H plus 5 2s are 10 electron. Right, everybody? Now we have to write the overall reaction, everybody. So let us deduct what is there. 10 electron will get cancelled. 16H plus 15H plus will get cancelled, right? 8H2O and 10H2 will get cancelled. So that means what are we left with? We are left with, everybody, 2MnO4 minus plus 5SO2, yes, plus 2H2O, right, plus 16H plus here, so H plus 1, and this will give us what? This will give us, everybody, this will give us, check it out, yes, this will give us 2Mn plus 2, and here 5HSO4 minus. So this is your balanced redox reaction. Guys, please tell me, did you all understand whatever is written here? Did we all understand whatever is written here, guys? Do we all understand this? Do we all understand this? Yes. Is it absolutely clear, guys? Absolutely clear? You had this reaction in practicals? Amazing. Chalo. Now moving on, guys, let us take a look at some balancing the disproportionation reaction. But before that, here are some important disproportionation reaction, everybody. Please go through each and every reaction, because these reactions have time and again come in your JEE Mains. They may ask you anything from this reaction, and this is basically, consider it to be your cheat sheet. Okay. Oxyacids of phosphorus, C +1 and +3 oxidation number. Here, these are the reaction. Oxyacids of chlorine, that is halogen, +1, +3 and +5. I showed you there, right? And here, these are the some important reaction. This is your cheat sheet, everybody. Consider this to be your cheat sheet. Please go through each one of them. Please go through each one of them. Now, guys, okay? This is done. This is done. Oh, this was repeated. One slide is repeated twice, so don't worry about it. It's okay. You will be anyway getting it. Now, guys, let us take a look at how to balance a disproportionation reaction here. Okay? So you have P4. P4 is in 0 oxidation state, because that is the elemental state. Am I right? Yes. Then in PH3, P is in -3 oxidation state, and in H2PO2 minus, if you calculate it, P is in +1 oxidation state. So from 0, it is going it is decreasing to -3, and from H2PO2 it is increasing to +1. Very good, Ramyashi. This is called as, after 7 parts of Ramayana, you are asking me, ma'am, Sita was Ram's dad or what? Ramyashi, that's basically the question, bacha. I have completely explained it to you, everything. See, bacha, MnO4, manganese is in +7 oxidation state. So +7 to +2. If it has to go from +7 to +2 oxidation state, it has to gain 5 electron, isn't it? That's how 5 electron, bacha. Please pay attention when I'm teaching you. Okay? Alright, so now what are we going to do, everybody? Chalo, let us separate it out. Okay, let us separate it out. So we will be getting P4, which forms H2PO2 minus, right? Yes. And just to balance it, let us add here 4 because we need 4P, because this side also you have P4, so we will need 4P. This is your oxidation half, because from 0 it is going to +1 oxidation state, right? Okay, and the second half of the reaction is your P4 forms PH3. To balance it, once again, let us add here 4. This is your reduction half, everybody. All right. Now what are we going to do? Let us multiply this with 3, can we? Because see, hydrogen is 3 here. Hydrogen is 3 here. Can we multiply it with 3? Let us multiply it with 3. So if we multiply this with 3, what will we be getting? We will be getting 3P4 forms 12H2PO2 minus. Cool? Alright, everybody? Yes. Now, that means the overall reaction will become, see, check it out, guys. It will be 3P4 and here is 1P4. So it will be 4P4, am I right? Plus, what do you have? You have OH minus, am I right? Plus, see, 12H2O. Just because here you have H2PO2. You have 12H2PO2. Chalo, we will write this later just to make you, just to explain this to you. This side you have 4PH3. So 4PH3 plus 12H2PO2 minus. This 12H2PO2 minus, you have to balance it out with hydrogen and oxygen. How will you do it? Let's add 12H2O here. Make sense? Make sense, everybody? Make sense or nonsense? Now, check it out, my dear students. On the LHS side, for the oxidation half. For the oxidation half, what do you have? What do you have here? You have you have P4. Here you have 12H2O, and you have this side, you have 12 plus 24. 12 plus 24, isn't it? 12 plus 4 3s are 12, and 12 into 2 is 24. Yes. So this will be, okay, let us write it down, everybody. Chalo. LHS, okay, LHS here, what do we see? We see 10, we see 1 OH minus. 1 OH minus, right? 1 OH minus here. And on the RHS, what do you have? RHS, how many oxygen do you have? 12, isn't it? Yes. See, 12 oxygen. No, right? One OH minus, and this side, if we calculate it, this side, it is RHS is 12 only. RHS is 12. Next, everybody, LHS is once again here 12H2O. This is 12H2O, and RHS here is what? This is 4 3s are 12 and 12 2s are 24. So 12 plus 24 is equal to 36, everybody. 36. Okay. Now, this whole equation that we have, this whole equation, we can simplify it, isn't it? After simplifying it, what will we get? We will be getting, everybody, everyone, let me write it in a different color. So we will be getting P4 plus 3OH minus plus 3H2O, and this will be forming PH3 plus 3H2PO2 minus. So this is how we are balancing a disproportionation reaction. All right, everybody? Yes. Now, my dear students, let us take a look at redox reaction in electrode process. Yes, in electrode process, everybody, what happens is these containers, they will be called as half cells. If you remember, in electrochemistry also we have learned it, isn't it? Yes. They will not ask you to balance the equation, but they will ask you that in the balanced reaction, how many electrons are there? How many OH minus ions are required? So balancing you must know. Balancing you must know. Okay? Alright. So these containers that you see, na bacha, these containers that you see, what are these? These are called as half cells. Okay? And the combination of these two together, we will call it as a redox couple. What is couple? Couple means two only, right? Couple, right? Pair, isn't it? Couple. When you form a couple, what do? Two people, right? Exactly. So a redox couple, we will define it as having together the oxidized part and the reduced form of the substance taking part in oxidation or reduction half cell. So basically, everybody, now if you take a look at it, what will happen? Do you remember the electrochemistry part, everybody? Do you remember the electrochemistry part? So here you have Zn, right? After some time, electrons are gathering up, and then what will they do? They will start moving through this wire and they will come here, okay? Now here also electrons are there, electrons have come now. These electrons, it will be grabbed by copper, and copper plus 2 will grab these electrons and it will start depositing it as copper. Everybody, do you remember this? Yes, this was your Daniel cell in electrochemistry we have studied. So here what do we have to remember? We have to remember red cat and ox. That means reduction always occurs at cathode. Why do we use a paste inside the salt bridge? Janine, we use the paste inside the salt bridge so that the electrolyte, the salt, can easily get into the solution. Okay? So that the salt can easily get into the solution. That's why we use a salt bridge. And oxidation occurs at anode. Okay? Alright, this is something that you remember, and from here you have the electrochemical series that we have once again studied in the electrochemistry chapter, electrochemical chapter or electrochemistry chapter. This is called as electrochemical series. This is there in your NCERT, and right here, so this is basically the ulta of the NCERT image, okay? Ulta of the NCERT image. In the NCERT image, you have fluorine on the top and you have lithium at the bottom. Here what we have done is we have added lithium in the top, fluorine at the bottom. So as you go from top to bottom in this picture, you will see that oxidizing nature is increasing, and as you go from bottom to top, you see that the reducing nature is increasing. Clear hai everybody? Yes. Now, what are the applications of electrochemical series, guys? Electrochemical series, they can tell you the strength of the oxidizing and reducing agent. And we know that the strength of the oxidizing agent is proportional to standard reduction potential. Do you have to memorize? No. But you must know some of them. You must know some of them, everybody, like zinc. Zinc has 0.76, okay? Just like, you know, zinc you must remember, alright? Yes. And you must remember that fluorine is at the top. Fluorine is at the top. Ag, copper, these ones you must remember, okay? Not all of them, not all of them. Anyway, the values will be given to you. Don't worry about it. The values will be given to you. So, strength of oxidizing and reducing agent can be told by the electrochemical series, and we all know that the strength of oxidizing agent, okay, the strength of oxidizing agent is directly proportional to your standard reduction potential, okay? What is it? Standard reduction potential. Am I clear, everybody? Yes, it is directly proportional to standard reduction potential. It can also tell you the standard EMF of a cell. You can calculate the E0 cell, and it can predict the feasibility of the reaction, everybody. So if strength of oxidizing agent is standard reduction potential, that means strength of reducing agent is inversely proportional to the standard reduction potential. Do you remember, everybody? Yes, EMF and all of these I have already taught you. I do not think we need to know. There is one more thing that it can do. It can also tell you that which metal can liberate hydrogen from acid, everybody. Only those metals which have a negative reduction potential, they can liberate hydrogen from acid. That means copper will not be able to. See, copper has a positive reduction potential. So those which are negative, that means those which are above hydrogen in the electrochemical series, they can liberate hydrogen gas. Okay? This reaction, if I give you an example, for example, everybody, if you take CuS plus if you take hydrochloric acid, supposedly you should be getting CuCl2 plus H2, right? But this reaction you will not be getting because copper is oxidized and hydrogen is reduced, which is not possible according to the electrochemical series. Am I clear, everybody? Is this understood, everyone? Is this understood, guys? Yes, yes, yes. Okay, now before N factor, here is one important term that you should know, and that, my dear student, is equivalent mass. What is equivalent mass, everybody? Can somebody tell me what is equivalent mass? Equivalent mass is basically mass of a substance which combines or displaces 1 gram of hydrogen. Okay, what is it? Mass of a substance. Mass of a substance, okay, which combines or displaces 1 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine or 100 gram of silver. This is called as your equivalent mass, everybody. Okay, this is called as your equivalent mass, everyone. Okay, equivalent mass can also be figured out molar mass divided by N factor, that we are just about to understand now. Okay, N factor can also be called as what? N factor is also called as valency factor, everybody. Okay, now let us understand N factor. What is the valency factor for acids? Okay, for acids it is the number of replaceable H plus ions. What is it? Number of replaceable H plus ions. For example, if it is HCl, H plus, 1 H plus, so that means it is 1 H plus. Yes, H2SO4, 2 H plus, right? So like that. Now for bases, what is it? For bases it is number of replaceable OH minus ions, everyone. Okay? Salts, total cationic or anionic charge. Okay? What do we write? Total cationic or anionic charge. Correct? That is called as salt. That is for salt, everybody. Very good if you have studied. And for cation or anion, my dear bachos, it is the charge on ion. What is it? It is the charge on ion. So we all know that an acid can only donate, right? Acids can donate H plus ions that are connected to more electronegative element. So if I take the example, everybody, if I take the example of H3PO4, what will you write? What will be the valency factor here? See, P double bond O, right? Then you have OH, then you have OH, and then you have OH. So everybody here, the valency factor is going to be HHH. That means 3 is the valency factor. Similarly, if you have H3PO2, everybody, please understand this, guys. Similarly, if you have now H3PO2, then what will you do? Draw the structure, guys. P double bond O. You have 1 H here, you have 1 H here, and you have 1 OH here. So here the valency factor is going to be only 1, not 2, not 3. Valency factor is 1. I have just told you. An acid can donate the H plus ions that are connected to more electronegative element. Which one is the more electronegative element? Oxygen is an electronegative element, hence that is what it is going to be. Okay? Chalo guys. Now let us understand the N factor of oxidizing and reducing agent. Chalo. MnO4 minus is the oxidizing agent and it changes to Mn plus 2 in acidic medium. That means our reaction is going to be, everybody, what is our reaction? Our reaction, we have just done it. MnO4 minus plus 8H plus 5 electron will form Mn plus 2, right? And 4H2O. Clear? So that means how many electrons are exchanged here, guys? How many electrons are exchanged? There are 5 electrons that are exchanged, right? Yes, 5 electrons that are exchanged. Now if you now check it out. MnO4 minus, once again, plus 7 oxidation state. In case of MnO2, it is plus 4 oxidation state. So that means our reaction is going to be MnO4 minus plus 3 electron plus 2H2O forms MnO2, and to just balance it, 2 2s are 4, so that means 4OH minus ion. Here how many electrons are exchanged, everybody? How many electrons can we write? 3? Absolutely. Yes. Now check it out. Next one, everybody. Next one. MnO4 minus once again is in plus 7 oxidation state, and it is forming MnO4 2 minus in basic medium. If you calculate it, you will find that here plus 6 oxidation state. So that means that we can write it as MnO4 minus plus 1 electron will give us MnO4 2 minus. That means here how many electron? Just 1 electron, everybody. Okay. Similarly, guys, for Cr2O7 2 minus to Cr3 plus, what will happen here? The reaction is going to be Cr2O7 2 minus plus 14H plus 6 electron, and this will form, everybody, 2Cr plus 3 plus 7H2O. That means how many electrons, guys? 6 electrons, everybody. You guys are understanding. Last one, everybody. Last one, everyone. We have done the example already. H2O2 forms 2H plus, and plus 2 electron will combine to give you 2H2O. That means here how many electrons? 2 electrons. Is this clear, everybody? Yes. Once again, this becomes a cheat sheet for you. Similarly, guys, can you do it for these 3 reactions? Can I give this to you as homework? Can I give this to you as homework? Will you all be able to do it? See, H2O2 and then it is changing to O2. I think you can do it. I think you can do it. Just write the equation and write down how many electrons. Can you all do this or not, everybody? Quickly tell me, can you all do this? Yes or no, people? Yes or no, guys? Yes or no? Yes or no? Yes or no? Yes? Okay. Now, guys, let us quickly move on towards titration. What is titration? Titration is a volumetric technique and it is a quantitative analysis. And what do we want to understand from here? What do we want to calculate? We want to calculate the concentration of a solution, but we do it with the help of a known concentration of another solution. Isn't that what we do? Isn't that what we do, everybody? So we have in a conical flask, we have something, right? We have something, correct? In the burette, we have something, isn't it? Yes. So this is called as analyte. Analyte, basically the solution in titration flask. What is the titrant? The titrant is the one that is taken in the burette, okay? Titrant is the one taken in the burette, and this is in conical flask, everyone. This is in conical flask, everybody. Yes, guys, do we know this? Now, the major important part that we all know is your acid-base titration. What do we do in an acid-base titration, everyone? In an acid-base titration, guys, what do? Usually, we want to find the amount of known acid or basic substance that can react with either the acid or the base, depends on whatever we have taken, right? And from there, we can calculate our volume, okay? From there, we can calculate the volume. So here, M and V are what? M is molarity, V is your volume, everybody. So M acid, V acid is equal to M base, V base, everyone. And in this case, we also use a indicator. Indicator is the substance that we all know can change. Yes. What do? We know that indicator can change the color to respond to a chemical change. And most of the time, what are the indicators that we use? We use phenolphthalein, we use methyl orange, we use litmus, and blah 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 blah, right? Yes. But remember, the whatever you have taken in the conical flask, that is your unknown concentration. Whatever you have taken in the conical flask, that is your unknown concentration. Whatever you have taken in the burette, that is something that you know. So here you are basically comparing, right? You do not know the acid unknown concentration, but you know the concentration of the base. So together when they react, that's how you find the quantity, the volume, everybody. Yes. All right. Now what you do here is, everyone, see, N1 M1 N1 M1 V1 is equal to N2 M2 V2. This is an important formula. From here we can calculate a lot of things, everybody. So N and N, this N1 and N2, what are these? These are your N factors. Okay. What is this V1 and V2? This V2 is the volume. This V2 is the volume. This V1 is also the volume Okay, what is M1? M1 is going to be your molarity, everybody. M1 is your molarity. Yes, this is your volume, and this M2 is also your molarity. Remember, you have two substances that you are comparing. You have two substances that you are comparing. Hence, you have to equate them. Okay, you equate them and you find out that what is what. Yes, guys, are we done with this? Now, shall we solve one or two questions, and after that we are done. It will be just last 10 minutes, everybody. Last 10 minutes, can you please give it to me? Last 10 minutes, can you please give it to me, everybody? Yes? Are we here with me? Are we going to solve some questions, guys? Can we solve some question, everybody? Chalo. Whatever I have taught you, the questions are based on that, everyone. So, chalo, read the question, everyone. The first question is 50 milliliter of 0.1 molar solution of a salt reacted with 25 milliliter of 0.1 molar solution of sodium sulfite. The half reaction for the oxidation of sulfite ion is, see, I have just done this, isn't it? I have just done this. We have just done this, isn't it? SO3 2 minus 2, it is forming SO4 2 minus, the same reaction. Now you have to find if the oxidation number of metal in the salt was 3. What would be the new oxidation number of the metal? Okay? Yes, what will be the oxidation number of the new metal? Am I clear, everybody? Shall we do it? Chalo, shall we do it? Queen baby start? Yes, bacha, we will be doing it soon. Don't worry about it. Very soon we will be doing it. Okay? So, chalo, let us do it, guys. First of all, here, let us suppose, okay, assume that new oxidation number of the metal will be X. New oxidation number of the metal will be X, because that is what we have to find out. We do not know what is the new oxidation number, right? We do not know it. Now, here if you check it out, you have SO3 2 minus plus H2O, which forms SO4 2 minus plus 2H plus 2 electron. Am I right? If you calculate the oxidation number of sulfur, you will find that right here in SO3 2 minus sulfur is in plus 4 oxidation state. Okay. In SO4 2 minus sulfur is in plus 6 oxidation state, everybody. What is the valency factor? Valency factor, it is given here 2 electrons. So that means that N factor or valency factor, same thing, everybody. So we can write that the N factor is equal to 2. Am I right? N factor is equal to 2, everybody. Make sense? Make sense? Okay. Now, according to the question, it is written that 50 milliliter of 0.1 molar salt. Yes, 50 milliliter of 0.1 molar salt is equal to 0.1 molar of 25 milliliter of what? Sodium sulfate. Sodium sulfate bole to Na2SO3. Am I right, everybody? Makes sense or nonsense, guys? Are we paying attention, everybody? Are we understanding this? How am I doing it? Now, from here, what we have just done, N1, M1, V1 is equal to N2, M2, V2. Exactly. So, here I can write M equivalent, milli equivalent of salt is equal to MEQ of Na2SO3. Am I right? Very good, everybody. Yes. So, that means we can write it as 50 milliliter. 50 is the volume multiplied with 0.1. Let's multiply it with N. We do not know N. And here we know we have everything, guys. Here we have 0.1 multiplied with 25, and we know the valency factor is 2. So multiplied with 2. That means if you equate it and if you calculate it, what will you get? You will get that N is equal to 1. Now we are given, see, the metal was in plus 3 oxidation state, right? The oxidation number of the metal is given that it is in plus 3 oxidation state. So from M plus 3 plus 1 electron will give you what? It will give you M plus 2. So that means that oxidation number, new oxidation number is 2, because 1 multiplied with 2 is going to be 2. Option C. Makes sense, everybody? Makes sense or nonsense? Guys, come on, calculate it, check. Please check, everybody. Does this make sense or not? Did you all understand this? Did you all understand this? Yes? Chalo. Let us go to the next question, everyone. The next question is, an element A in a compound ABD has oxidation number AN minus. It is oxidized by Cr2O7 2 minus in acid medium. In the experiment, 1.68 into 10 to the power minus 3 moles of K2Cr2O7 were used for 3.26 into 10 to the power minus 3 moles of ABD. What is going to be the new oxidation number of A after oxidation? Once again, we'll be using the same formula, guys. The same formula, everybody. Milli equivalent of K2Cr2O7 is going to be equal to milli equivalent of A, B and D, everyone. Yes? A, B, D, everybody. Yes, so that means that what we have to do? We're going to write it as N factor of K2Cr2O7, N factor of K2Cr2O7 in acidic medium. What is the N factor of K2Cr2O7 in acidic medium, guys? Can somebody tell me what is it? It is 6. Okay, it is 6, everyone. Okay, all right. Okay, everybody. Yes. Now here you see that what is written, guys. See what is written. 1.68 into 10 to the power minus 3 moles, right? So that means 6 multiplied with 1.68 into 10 to the power minus 3. And that we will equate it with x, because we do not know x multiplied with 3.26 into 10 to the power minus 3 of ABD. Calculate this, guys. What will you get? Calculate. What will you get? Come on. Calculate. Calculate and tell me what will you get, everybody? Yes. What is it going to be? 6 into 1.68 and 3.26. Calculate. What will you get for x value? What is the value of x? 10 to the power minus 3, 10 to the power minus 3 can be cancelled, right? 6.168. 6 8 is 8 5 is 8 5 is 40, 8 6 is 48. So guys, what is it? Calculate and tell me. I suppose it should be 3, no? I suppose it should be 3, isn't it? Let's calculate it and see only. 1.68 multiplied with 6 divided by 3 point. No. Huh. 1.68 into 6 divided by 3.26. 3. X is equal to 3. Now what do we have to do, guys? Now last but not the least, 3. Thank you so much. Thank you so much. ABD, do you see your name is in the question? ABD, do you see? Do you see? Your name is in the question. Yes. We have milli equivalent of ABD. Very nice. So x is equal to C. So what x is equal to 3. Sorry, 3. So now new oxidation number or new oxidation state is going to be new oxidation state of A to the power n will be what? A to the n minus, right? So it will be minus n plus 3. That means we can write it as 3 minus n, and 3 minus n is your answer. So option B is your correct answer. Abe Hari. Shh. Why are you disturbing the class, bro? Can't you see I'm taking the class? How will I go and have lunch? While taking the class, I will have lunch or what, huh? Will it look nice? Don't spam, no? Study what I'm teaching you. Next question, guys. The incorrect order of decreasing oxidation number. The incorrect order of decreasing oxidation number of sulfur in compounds is, everybody. Chalo. So we have in the option A, CH2S2O7 first. Shall we calculate the oxidation number, guys? See, we all know that oxygen is in -2 oxidation state, hydrogen is in +1 oxidation state, and for sulfur, let us assume that it is X. Okay? Do you all know how to calculate oxidation number? So it will be 2 multiplied with 1 plus 2x because 2 sulfur. Okay? Plus 7 multiplied with -2. That means how much will you be getting? See, there is no charge, no overall charge. So equate it with 0. Once you do it, now you will get 2x is equal to 7 2s are 14. 14 minus 2 will be how much? 12. Yes. So let me write here 12. That means that x is equal to +6, everyone. So sulfur here is in +6 oxidation state. Clear? Alright, yes, yes, this will be available later also. Then here you have Na2S4O6. Let's calculate it, everybody. Sodium will show what? +1 oxidation state. Oxygen will show you -2 oxidation state. Let us consider that sulfur is X. That means it will be 2 multiplied with +1 plus 4X plus 6 multiplied with -2 is equal to 0. That means what will we get? We will get 4X is equal to 10. So that means that X is equal to 5/2. Am I right? Yes, everybody. All right. So here it will be how much? Here this is your 5/2, everybody. Similarly, if you calculate it for Na2S2O3, you will be getting that this is your 2 and S8 it will be 0. So this is absolutely correct. It is decreasing only, right? It is decreasing. This is correct, everyone. Yes. How you find N is equal to 6? Where? In K2Cr2O7. Acha bacha, I knew the oxidation state, right? I knew the oxidation state. Also, if you remember, I have just calculated it for you here as well. See, Cr2O7, K2Cr2O7, 2Cr plus 3. K2Cr2O7 will go to C. Here it is written, right? Acidic medium. In acidic medium, Cr2O7 2 minus gets converted to Cr plus 3. So from plus, so there is a give and take relationship of 6 electron. And here is the reaction, bacha. I have taught you. See, here, this is the reaction. Cr2O7 2 minus plus 14H plus 6 electron will form 2Cr plus 3. Okay, alright. That is how I figured it out, that N factor is your 6 electron. Surekha, my name is Nabamita Bhattacharji. Are there any question like this in JEE? Dhanush, what do you think? Am I passing your time just like that, huh? Am I wasting your time? These are JEE Mains previous year question, by the way. Exactly similar questions have come in JEE Mains previously also. Okay? So yes, this is why I'm doing it. Okay, now everybody, similarly, if you do it for option B, option C and option D, you will be able to calculate it. By the way, let me tell you what is the correct answer. The correct answer is actually, that means the incorrect order is option C and option D will have the incorrect order. But can I give this to you as homework? I think you will be able to do it. You just have to calculate the oxidation number. Will you all be able to do it? Will you all be able to do it, guys? Yes or no? Yes or no? Yes, I believe that you will all be able to do it. It's very simple, guys. Very simple, everybody. Okay? Chalo. Next question is, which of the reaction does not represent auto-redox or disproportionation reaction? Which one of these are not a disproportionation reaction? Chalo, let us check it out, everybody. See, if you look at the first option, you have Cl2. Cl2 is in 0 oxidation state. Yes. And from there, it is going to -1 oxidation state. In ClO3 minus, 3 2s are 6, but there is a minus, so 6 and -1, so it will be +5 oxidation state. This is definitely a redox reaction. This is definitely a redox reaction, right? Yes, we don't have to even consider that anymore. 2H2O2, we have seen a lot of examples, so we know that 2H2O2, here, what will happen? Oxygen is in -1 oxidation state. It goes to -2 oxidation state, and here it will be in 0 oxidation state. So this is also disproportionation reaction. Now look at Cu. Cu here is in +1 oxidation state. It goes to +2 oxidation state, right? And from there it also reduces to 0 oxidation state. So this is also disproportionation reaction, right? Very good. But if you look at this last example, everybody, in the last example, check it out. NH4 Cr2O7 forms N2 plus Cr2O3 plus 4H2O. This is your reaction, isn't it? Here nitrogen is in +3, no, not +3. Here nitrogen is in -3 oxidation state, guys. Okay, -3. But chromium is in +6 oxidation state. Here nitrogen is in 0 oxidation state, and chromium here is in +3 oxidation state. So that means chromium is going through redox reaction, chromium is going through reduction, and nitrogen is going through oxidation, isn't it? Nitrogen is going through oxidation. But one element is not simultaneously. Yes, one element is not simultaneously going through reduction and oxidation. This is a redox reaction, but it's not a disproportionation reaction. Am I clear? So yes, option D is your correct answer. Chalo guys, one last example, after that I'm done. My voice is going off and I need to take a little bit of rest now. Okay? I think it's more than 2 hours now. See, within 2 hours I've completed the session with a lot of examples as well. And everything, top to bottom, everything I have, yes, top to bottom, everything I have covered, isn't it? Yes, chalo. So here what do we have to do? We have to match the list of compound 1 to compound 2, everybody. Now let us calculate the oxidation number C for NaN3. For NaN3, how do we calculate? We know that sodium has +1 oxidation state. So 1 multiplied with +1 plus 3 multiplied with X. Yes, it's equal to 0. That means X is equal to -1/3. Am I right? Very good. Next is N2H2. For N2H2, if we calculate, we know that 2 multiplied with X. Achha, chalo, we will come here. Okay? We will come here. Okay? Okay. 2 multiplied with X plus 2 multiplied with +1. If we calculate this, then what will we get? X is equal to -1. Am I right? Yes, very good. Next we have NO. For NO, if you calculate 1 multiplied with X plus 1 multiplied with -2, it's equal to 0. That means that X is equal to +2. Am I right? And finally, the last one is N2O5. For this, if we calculate, how do we calculate? 2 multiplied with X plus 5 multiplied with -2 is equal to 0. That means X is equal to +5. है ना? So will you all be able to do it? I think this is easy peasy. So N2O5 is +5. NO is +2. Right? N2H2 is -1 and NaNO3 is -1/3. So option A is 3, B is 4, C is 2, and D is 1. So I think option A is your correct answer. Option A is your correct answer. With this note, everybody, we have come to the end of the session. Thank you so much. Thank you so much. I hope you understood everything. Do not forget to share your feedback in the comment section. And this is your Vedantu JEE English channel, everybody. Do not forget to like, share and subscribe. Do like it if you haven't liked the session. Do share it with your friends. And don't forget to subscribe to the channel if you are a new student. Now, I'm going to send you the Telegram channel right here, right now, everybody. See, I'm sending you the PDF. I'm sending you the PDF. Here we go to the Telegram channel. And here you will see everybody. Arey, what happened? Quick share did not work. Huh? Working again. Working again. And here I am sending it to the Telegram channel. See, this is Vedantu JEE English channel, guys. Can you see? This is Vedantu JEE English channel here. Right here. Sending it, everybody. And send it. Okay? Yes? Okay? I am so sorry, Muthulakshmi. I do not know. I have been taking session. I haven't had a conversation with her. Okay, I haven't had a conversation with her. So I'm really sorry. I do not know, bacha, if she has taken the class or she has not. Okay. My next session will probably be tomorrow. Tomorrow I will be taking you through the EMCET and VIT EEE strategies, everybody. Okay. So I'll be taking you through the strategies, and there might be a shorts that I will send everyone how to memorize it. So please do watch it. Please support us. Thank you so much. I will see you all very, very soon, and lots of love. We will also be launching some very amazing sessions, everybody. So stay tuned to the channel, and you must tell your juniors as well to follow this channel. Okay? Tada, bye-bye. I'll see you very, very soon. Bye. Very soon, very soon. You will see it in the channel only, but I do not know the time yet. Okay? I do not know the time yet, but tomorrow you will see me. Tomorrow you will see me. Okay?